Welcome, students. We're going to be talking about polynomial and synthetic division, as well as complex numbers. The keys here are long division by polynomials, synthetic division, and what that would imply, complex numbers and their operations, and finally, quadratics and finding complex roots, okay? This will be the whole lesson, so we'll break it probably into 3 videos. And if you have any questions during those videos, please make sure you keep noting them. So I'm actually going to show you the notes. So the notes have the definitions first. And actually for long division, we're not going to write the definition. It is in the book. It is an aspect of the book, but it's not required for us to write. So let's actually practice it, if that makes sense. So let's practice long division, okay? Now the book sets it up this very idea, plus 16x minus 4. So we will be doing problems with both synthetic division and long division on the whole thing. Okay, so first things first, we are going to look at how x divides into 6x cubed. And so you write that, so that will divide 6x squared. Now notice I write the same power over the same power. Okay, that's just to keep it organized. So then I multiply this times x minus 2. I get 6x cubed minus 12x squared. Okay, then I subtract that. I get 0, and I get minus 7x squared plus 16x. Okay, let's do the same thing. I see how many times is x. Divide into negative 7x squared. So that divides in negative 7x. Multiply that. I get negative 7x squared. And then this becomes positive 14x. Okay, I'm subtracting this also. So it becomes 2x minus 4. Now, how many times does x go into 2x? Plus 2. This becomes divided by 2x minus 4. And you get 0. So our quotient, well, our quotient is our q of x is going to equal 6x squared minus 7x plus 2. Okay, now the key here is finding remainders. So we're going to do another practice problem. And actually there's these 3, 1, 2, and 3. But there's the division algorithm. So we're going to talk about the division algorithm before we do number 2 and number 3, okay? Let's look at the division algorithm. I hope it's not cut off here. Okay, it's just barely. So we'll zoom back out a little bit. Okay. Okay, and we'll actually blow this up for a second so that it's clear. Okay. So the division algorithm. If f of x, so we're writing this in, if f of x and d of x are polynomials such that d of x does not, equal 0. So such that, and the degree of d of x is less than or equal to the degree of f of x. There exists unique polynomials, q of x, and r of x such that okay, such that f of x equals d of x times q of x plus r of x. Or, you could say it differently. You could say f of x divided by d of x equals q of x plus r of x divided by d of x. Okay, where r of x equals 0, or the degree of r of x is less than the degree of d of x. Okay, if the remainder, the remainder r of x is 0, d of x divides evenly into f of x. Okay, so breaking this down for a second. If you have this, this is the division algorithm. Q of x is our quotient. This means after you divide what you get left, r of x is our remainder. Either r of x is 0 or it's not. If it's 0, then you say d of x divides evenly into f of x, or d of x is a factor of f of x. If r of x is a different number, it always has to be less, the degree always has to be less than the degree of d of x, okay? Okay, let's practice the problems. Zoom in a little bit more. Okay, so let's practice this first one. Now let's do the second one. So if we're dividing x cubed minus 1 divided by x minus 1, we need to first add the things that are not there if we're doing long division. So we add x squared, x, and then we have 1. And the reason why we do this is because in long division we need to make sure we have each place, okay? Okay, dividing. So x goes into x cubed, x squared times this by x minus 1, we get x cubed minus x squared. This becomes, subtract it, this becomes positive x squared, and drop down to 0x. Then again, we're going to say that we get an x, just an x, so we get x squared minus x, and we get just positive x minus 1. We're going to add 1. X minus 1. Okay, so quotient q of x is going to equal x squared plus x. Sorry, x squared plus x plus 1. Okay, sorry that that's a little bit messy. Just writing at a straight angle. Okay, let's try the last one of these examples, and we'll move on to the next part of this on the next video, okay? Okay, if it's out of order, you need to write it in order. So I'm just going to write it in out of order. 2x to the 4 plus 4x cubed minus 5x squared plus 3x minus 2. I'm going to divide this by x squared plus 2x minus 3. So x squared goes into x to the 4, 2x squared times. Multiply this out, we get 2x to the 4 plus 4x cubed minus 6x squared. Subtract this, we get, this cancels, that cancels, this becomes x squared plus 3x minus 2. X squared goes to x squared plus 1 times, so we get x squared plus 2x minus 3. Subtract it, we get x plus 1. Okay, so we have our quotient, 2x squared plus 1. We have a remainder, x plus 1. Okay, now you can write this multiple ways. The way they write it in the book is they write, they show this division and then they say equals to 2x squared plus 1 plus x plus 1 over our divisor, which is x squared plus 2x minus 3. Okay, that will be that for that example. We will come back and work on synthetic